Welcome to Veteach, the continuation of the series of my lecture. In my previous video, what we had to discuss is the contents of the probability, addition theorem of the two events, and also along with the conditional probability and the Bayes theorem. These concepts you have to seen in my previous video. The continuation of this distribution concept. In that, the variable is to be present. So in that variable, that is, can discriminate into the two parts. The first one is called as discrete random variable, and the second one is continuous random variable. So depending upon that, we have to discriminate the distributions are like this: binomial distribution and Poisson distribution, normal distribution, and also uniform distribution, like that. Whatever the variable is to be present in the distributions, we have to classify like this. So depending upon the values of x are to be finite, so then only the distributions are to be classified like this. So in that, the binomial distribution concept is there. So binomial distribution, here the number of trials are to be occurs. Here in that, x number of the success are to be available, where p is called as the probability of success and q is called as the probability of the failure. Q is called as the probability of the failure and p is the probability of success. Then p plus q is equal to 1, because the summation of the success plus failure is equal to 1. So in that concept, so that is, we have to discriminate the probability density function has to be p of x is equal to x, that is equal to NCR into p to the power of r into, that is, q to the power of n minus r. So simply you can take it as to be in place of x by either small x or small r. That is equal to 0 in otherwise conditions. 0 in otherwise conditions. Like that, we have to define the probability density function like this. We have to define in this way. Now we have to construct or fit the binomial distribution into the coordinate plane, that is fitting of a binomial distribution. That we have to take the concept of let us suppose that n trials constitute an experiment. If this experiment is to be repeated n times, then the frequency function of the binomial distribution is given by, so f of x is equal to, so this is Kaplan into p of x. This is what we call it as a expected distribution. So like that, so we can take the x values are to be 0, 1, 2, 3, so on. Yeah. So like that, so here the parameters are n comma p. So where n value is to be finite and p value is to be the probability of the success. So these are the parameters. Now, so by using of this, derive a theorem on the binomial distribution, that is mean of a binomial distribution. Mean of a binomial distribution. So that means, so what we call it as in my previous videos, that is the first moment generating function e of x is equal to, so that is equal to sigma of x is equal to 0 to n. So x into, so p of x is equal to x, or simply that is also called it as nu of x value. This is for the discrete distributions only. So therefore that is equal to here, so you can take it as to be, so sigma of x is equal to 0 to n. That means here I have to take as sigma x is equal to 0 to n. So p of x value is to be ncx into p to the power of x into q to the power of n minus x only. Will you catch my point? Now, so then this is equal to, so I have to apply the formula for NCR. So NCR is equal to n factorial by n minus r factorial into r factorial. This formula I have to apply. So then this is equal to sigma of x is equal to 0 to n, x is equal to 0 to n factorial by n minus x factorial into p to the power of x into q to the power of n minus x. Now I have to expand of this only one step forward only. So for that purpose only I have to take sigma of x is equal to 0 to n, sigma of x is equal to 0 to n. So this is n into n minus 1 factorial by, so this is n minus x factorial into x minus 1 factorial into p to the power of x minus 1 into, so p into q to the power of n minus x. Will you catch my point? So then this is equal to, so because I have to convert this sigma of x is equal to 1 only. Sigma of x is equal to 1. So because I have to expand, we have to expand one term forward. That is why I have to take it as to x is equal to 1 to n. Now this is sigma of x is equal to 1 to n. So these n into p are the independent of x terms. Those two terms I have to bring as in front of the sigma notation, that is equal to n into p. And then this is n minus 1 factorial by n minus 1 factorial by. So here this is the expected value, that is e of x value. X is to be there here. So that means we have to cancelize the term. So for that purpose only, I have to take here xx has to be cancellized. Xx has to be cancellized. This is now then this is value is to be, so n minus x factorial into x minus 1 factorial. So x minus 1 factorial into p to the power of x minus 1 into q to the power of n minus x. Then this is equal to n into p into sigma of x is equal to 1 to n. So this is how can you write n minus 1 into c x minus 1 into p to the power of x minus 1 into q to the power of n minus x. Now we have to expand the first term. So that is equal to, this is np into, first I have to expand x is equal to 1, that is n minus 1 c naught. So p to the power of, so 1 minus 1 is to be 0. So into q to the power of n minus 1 plus n minus 1 c1 into p to the power of 1 into q to the power of n minus 2 plus n minus 1 ct into p to the power of 2 into q to the power of n minus 3. Like that I have to expand the last term this way. Then this can be written as np into, so from the binomial distribution or binomial theorem, what we have to conclude, that is p plus q whole to the power of n minus 1 only. So then here whatever the property you have to learn, this is p means probability of success and q means probability of the failure. The summation value is equal to 1. Therefore that is to be np into 1 to the power of n minus 1, that is equal to n into. So this is the first moment generating function of the binomial distribution. U is equal to the expected value of x is equal to x, that is equal to np. So I think this is very, very important for the 10 marks question. So in the examination point of view, that are to be asking for. So find the mean and variance of a binomial distribution. Like that the question is to be asking. Next one. In that similar way, the variance. Variance is equal to, so e of x square minus e of x whole square. So this is the formula what you have to learn. So in the previous videos. So this is the variance, that is the difference of the second moment generating function to the mean of whole square. That is represents the variance v of x. Now I wanted to find e of x square value, that is equal to, so sigma of x is equal to 0 to n, because n value is to be finite. In the binomial distribution, n value is, we can take it as to be only finite value. So then x square into p of x is equal to x, that is equal to sigma of x is equal to 0 to n. So in our convenience way, I have to write it as to be x square minus x plus x. Like that, one x value is to be subtracted. After that, I have to add that one to x square. And p of x is equal to x means, that is ncx into p to the power of x into q to the power of n minus x. So that is equal to sigma of x is equal to 0 to n. I wanted to take this one as to be the first term, that is I have to take x as to be common, x into x minus 1, x into x minus 1 into, so ncx into p to the power of x into q to the power of n minus x plus, next one sigma of x is equal to 0 to n, so this is x into ncx into p to the power of x into q to the power of n minus x. So I think this may be, there is not there is any consider for evaluation of this, because that already had evaluated. So this is x value is to be there. That means this is the first moment generating function that already had to aware of this, that is np value. Now, so here this is x into x minus 1 is to be there. So I wanted to cancelize the terms. Just we can forward two steps from this. Therefore, that is sigma of x is equal to 2 to n. So then x into x minus 1 into, this is n factorial by, so n minus x factorial into p to the power of x into q to the power of n minus x. Now here, so this is equal to, had expand the two terms, that is x is equal to 2 to n, x into x minus 1 into n minus 1 into n minus 2 factorial by, so n minus x factorial into x minus 1 into x minus 2 factorial into p to the power of x into q to the power of n minus x plus np. Will you catch my point? Now here x into x minus 1, x into x minus 1 both are to be cancelled here, and n into n minus 1 value and p to the power of, this I have to written as so p power x minus 2, p power x minus 2 into p square. In the next step I have to written that one. So then this is sigma of x is equal to 2 to n. So this is n into n minus 1 into n minus 2 factorial by, so n minus x factorial into x minus 2 factorial into, this is p power x minus 2 into p square into q to the power of n minus x plus np. Because in our convenience we have to write like this. Here p square term and n into n minus 1 are both are the independent of x terms. That is why I had to bring those terms in front of the sigma notation. That is n into n minus 1 into p square into sigma of x is equal to 2 to n. This is n minus 2 factorial by, so n minus x factorial into x minus 2 factorial into p power x minus 2 into q to the power of n minus x plus np. This how can write it as, that is n into n minus 1 into p square into, this is sigma of x is equal to 2 to n, this is n minus 2 c x minus 2 into p to the power of x minus 2 into q to the power of n minus x plus np. Now I have to expand from sigma to n terms, that is n into n minus 1 into p square into, I have to expand x is equal to 2. That means n minus 2 c naught into, so p to the power of 0 into q to the power of n minus 2 plus n minus 2 c1 into p to the power of 1 into q to the power of n minus 3. Like that we have to expand up to the n terms only plus n into p. Now, up to this, how can you write this? N into n minus 1 into p square into equal to, that is p square into p plus q whole to the power of n minus 2 plus np. By the binomial theorem, that we have to expand of this total term as to be written as p plus q whole to the power of n minus 2. So already aware of this, P means probability of success and Q means probability of failure. The summation value is equal to 1 here. Then n into n minus 1 into P square into, so 1 to the power of n minus 2 plus np. So that is equal to n square into P square minus n into P square plus n into P only. Will you catch your point? So this is E of x square value. So that means the second moment generating function of the binomial distribution. I wanted to know the variance value. That means so v of x is equal to e of x square minus e of x whole square. That is e of x square value is n square p square minus n into p square plus n into p minus of n square into p square. Because already aware of this in my previous video, that is n into the mean of a binomial distribution is to be np. So np whole square means n square p square, both are to be cancelled here. From those two terms I have to take np as to be common, that is 1 minus p. So that is equal to, so np into q, because p plus q is equal to 1, then we have to bring this p into the right hand side, then q is equal to 1 minus p. Therefore, the variance of a binomial distribution is to be NPQ and the mean of a binomial distribution is equal to NP only. These two theorems are very important for external point of the examinations. Please all of you be careful of about this. Like that, this is the variance value is to be getting here. In the next video onwards, we will go for the problems on binomial distribution. Thank you for kindly.